In this video, we're going to be looking at fatigue and life cycle for vertical axis wind turbines, and we're going to compare it to horizontal axis wind turbines with respect to the blade itself. So this video is titled VAWTs Part 1, a positive outlook on fatigue analysis and life cycle. This video is going to consist of several calculations. These calculations are only being done in order for the viewers and the learners to have a grasp of the scale, the magnitude, and the behavior of stress and the cycles of fatigue for wind turbines as it pertains to vertical axis wind turbines. This does not consist or does not represent actual values when being calculated. That being said, let's go into this video. So first of all, we have the revolutions per minute for a H rotor or a Darius. So when you are talking about the revolutions per minute for cycle lifetime, we are considering for a 4 kilowatt wind turbine system with an operating wind speed of 12 meters per second. At this wind speed and this rating of the wind turbine, you are talking about 2 meters in radius. So with a tip speed ratio of 6, which is the optimum for Darius wind turbines, we'll be able to estimate that the revolutions per minute is 344, which is quite a high number for a small wind turbine. So if you are talking of a horizontal axis wind turbine for a 4 kilowatt system with the same operating wind speed, you are talking of 3 meters in radius. So when you have your tip speed ratio of 6, in this case you are going to be getting a revolutions per minute of 230, which you will see immediately that the revolutions per minute for vertical axis wind turbines is about 50% more than the horizontal axis wind turbines. So the relation between revolution per minute and number of cycles. So SN cost parameter. So when you want to estimate the number of cycles based on this revolution per minute, you have RPM times 60, which is 60 minutes times T, which is the total number of hours for the duration of consideration. So N is number of cycles, RPM is the speed in revolutions per minute, T is operating time in hours. So number of cycles for VAWT and HAWT. So for a VAWT, with that RPM, you are getting about 5.4 times 10 raised to the power 8. And for a HAWT, you are getting about 3.6 times 10 raised to the power 8, which is still the same 50% more. But it doesn't just stop here, because when you come to stress reversal and cycle reduction, you will see that for this same number of cycles, which may look large, it may look close for both the VAWT and the HAWT, you realize that for the VAWT you have fluctuating aerodynamic load occurring twice per cycle, then bending stresses reversing between tension and compression. The stress cycle is reversed, large amplitude is created with no big mean stress offset. So you see that you have extremes of stresses acting on the vertical axis wind turbine. Then for the horizontal axis wind turbine, you see that there are steady centrifugal stress, except for cases where you have turbulence or gust. Also, the gravity reverses once per cycle, but the gravity compared to the wind load is negligible, so it doesn't really have so much of an impact on the system. You look at the behavior of stress, the stress cycle, the stress pattern. At the top is for the VAWTs. So you can see how there are multiple, like twice every 360 degrees the stress changes. And if you look at the gradation on the left, you see that it reverses from positive to negative in which case if you are going to do an estimate for the actual stress, the stress range is going to be quite high compared to a horizontal axis wind turbine that doesn't have stress reversal. So you see that the stress is far more. Looking at this chart here, you can see this is typically what an SN curve looks like, in which case you have your number of cycles on the horizontal and the stresses on the vertical. So you see that as the stress increases, the number of cycles reduce. You can see here that you have 10 raised to the power 8 in terms of number of cycles for this particular material, which is thermoset composite material. So you see it gets up to 10 raised to the power 8, and you see how you actually have increase in stress leads to reducing number of cycles. So yes, apart from the 50% that the VAWT uses to overtake the HAWTs, even in terms of the stress, because of the stress reversal, it also reduces the number of potential cycles for a vertical axis wind turbine system. So from this, you'll be able to have a grasp as to why VAWTs last 2 to 3 years or 2 to 5 years, while HAWTs can last from 20 to 30 years, majorly because of the behavior of vibration, stresses, fatigue that leads to this. But the issue is not just to abandon VAWTs. We need to look at it closely to see whether it's economical to install a VAWT every 3 years. Then it means that you're going to be targeting a project duration of 3 years. Every 3 years, a replacement of the VAWT system is carried out. In which case, it doesn't matter whether a VAWT can last for 10, 15 or 20 years, because even on a 3-year lifespan is running on, it's economically viable. Thank you for watching this video. This is Catherine of Resources, where we create for better living.